This video clip explains graphing systems of inequalities when manipulation is required or solving. For example, 3x plus 4y is greater than 12. It's not obvious to me how to graph that unless I get the y all by itself. So I'm going to subtract the 3x from each side. So 4y is greater than 12 minus 3x. I'm still not sure how to graph that. But if I divide by 4, then I have y is greater than 3 minus 3/4 x. That I can graph. So I start out at 3 on the y-axis. Then I go down 3 and over 4. I'm going to connect that with a dotted line because there's not an equal. And I'm going to shade above because it says y is greater than. 5 is greater than 3, for example. So I'm going to shade everything above that. In the other inequality, I will subtract an x from each side. So negative y is greater than or equal to 5 minus x. Let's get that to be positive. When I divide by a negative, then the inequality sign reverses direction. So a negative divided by a negative is positive. A positive divided by a negative is negative, and a negative divided by a negative is positive. So I would start at negative 5 on the y-axis, and I would go up 1 over 1. It says y is less than or equal to. Because of the equal, it's going to be a solid line. And it says less than. So the region that satisfies both inequalities is out here. Let's try another one. Let's get the y all by itself. Let's add 3x to each side. So negative 12y is less than or equal to 48 minus, plus 3x. Let's divide by negative 12. So y, when I divide by a negative, it inverts the inequality, flips it around. 48 divided by 12 is 4. Positive divided by negative is negative. Positive divided by negative is negative. 3 divided by 12. Well, we could write that as 3 over 12. That could be reduced because 12 could be written as 3 times 4. So let's rewrite the 3/12 is equal to 3 over 3 times 4. 3 could be written as 3 times 1. 3 divided by 3 is 1. And that reduces to 1/4. So y is greater than or equal to negative 4 minus 1/4 x. I could still graph it at the negative 3/12 x, but on this graph, going over 12 would take me clear off the chart, so it makes it easier if I take it to simplest terms. Let's solve the other inequality. Let's add 8x to each side. So negative 8y is less than 32 plus 8x divided by negative 8. So y is less than, oops, I divided by a negative, so it flips the inequality around. Y is greater than, 32 divided by 8 is 4, positive divided by negative is negative. 8 divided by 8 is 1, positive divided by negative is negative. I'm not going to write the 1, usually just write minus x. Okay, so go to the first inequality. I would start at -4 for my y-intercept. Then I would go down 1 over 4. And then it says greater than or equal to, so it's solid. Everything above 4 is greater than -4, for example. Y is greater than -4 minus x. So this one also crosses the y-axis at -4, but it goes down 1 over 1. And it says greater than. So it's dotted line. And everything above there. So the region of both of those is something like that. I guess I need to remember that is still dotted over there. So if a point were right on that line, it would not satisfy the inequality.